Okay, vector fields. So back to if we went to a single variable, we looked at our vector fields as derivatives of every point given the graph of the function. Same thing applies in multivariable, but now we're just going to 3 dimensions for now. So fundamental fact, right, one of the biggest things when it comes to vector fields is like flow of water. That's one of the biggest mechanics when it comes to multivariable calculus is how is water flowing or fluid from one to the other, or how things are waving. So one of the biggest examples of vector fields is currents. So how currents are formed or done in the ocean. And you could see like a simple little current here, right? If this is like a rock or a little paddle, the vector fields are going in one direction and the other, and they're bending depending on what, the curve is going to be. And that's what we're going to describe here is how do we, construct vector fields given a function itself. Okay. So first we'll just define it. We'll do an example of it. So the dB is set out in R2. A vector field in R2, so in 2 dimensions, is a function f that assigns each point x and y in D a 2-dimensional vector f of xy. Okay. And if we go into 3 dimensions, we'll talk about a little bit. So let E be a subset of R3. Then a vector field in R3 is the same process. There's some point x, y, z in E. Therefore, I can represent it as a vector in 3 dimensions, x, y, z. But for now, we'll do the easy part. How do we do vector fields in 2 dimensions, just in the xy plane? Okay. The process are roughly the same as single variable. You guys have already seen this probably in a little bit way back in the day. So here's our vector here itself, and we want to just sketch some of the vector fields based off our vector here. Okay. So the easiest way to deal with it is just make a t-chart. Now this t-chart is going to be a little different, however. We're going to have a point x, y, and then the output is going to be the vector f at the point x, y. Okay. So how this works out is just we're going to pick a couple points. Let's say we picked 1, 0, negative 1, 0, 2, 0, 2, 2, and we'll just do the opposites, for instance. Okay. So now we're going to plug these points into our vector. Now be careful when it comes to it, right? This is negative y I plus x. So we actually got to flip these around. So 0 is going to be in for y, and then 1 is going to be in for x. So we get the vector 0, 1. Now we plug in 0 in for y, which is going to get 0 for the I component. Plug in negative 1, we get negative 1 for the jth component. And we keep doing it all the way down portion. So here, 2, 0, so 0 is for y, 2 is for x. Plug in 2, 2. Now this time it's going to be 0 in for x, so the jth component is going to be 0, and be negative 1 for the ith component. And same thing down here, like that. Okay. So how do these look like? Okay, so first we're going to graph the point 1, 0. Okay, so 1, 0 right here. Okay, so now we're going to graph the vector 0, 1 at this point. So we're going 0 on the x and going up 1 on the y. So the vector looks like this. Okay. Next point, negative 1, 0 on the other side. Now this time I'm not going anywhere on the x, but I'm going down negative 1 on the y. There we go. Okay. Next one, 2, 0. So 2, 0. Again, I'm not going anywhere on the x, but now I'm going up 2. So So my vector looks something like this. So let's double it. All right, next point, 2, 2, which is right here, the end of the tip of this portion. All right, so this one's going -2, 2. So I go 2 to the on the negative side of the x, and then I go up 2. Yeah, right there. There we go. Next point, 0, 1, right here. So now this time I'm going -1 on the x, and I'm going anywhere on the y, so I'm just going flat this way. 0, oh, did I already? Oh, 0, 2 up here, right here. 0, 2. And this one's going -2 this way and nowhere. So to understand roughly where the graph, the vector field's going, we'll pick a couple more points. So we'll pick, to finish up, looks like I'm going in a circle here, this point right here, which is going to be 0, -1. So that gives us the vector, plugging -1 makes it +1, and then 0. So at this point, I'm going positive on the x, and I'm going nowhere else on the y. So you can kind of tell that these vectors' fields are going in a circle this way, outwards. That's pretty cool. So it's kind of like a whirlpool when it comes to this vector field. Okay. And the cool thing is we can actually see the direction of the vector field. So again, when it comes to flow and currency, you could see the currency going in one direction. And when you go into electromagnetism, or you see the magnitude of where it's going. So the energy fields is going, or the force fields in which the magnets are rotating the fields together. And that's what vector fields are all about. Now, in 3 dimensions, it's much more complicated, especially how to graph it, but it's the same concept when it comes to finding the vector fields. So let's suppose our vector field here is the vector yj plus zk. All right, so now if we just now have to graph this in 3 dimensions, and now again we're going to do the same thing. Now we're just going to have 3 points instead of 2 points. Or in this case, you want I, J, and K. So in this case, since we have no I, the x is going to be constant. Whatever the is here, it's going to be there. So let's start with the point 0, 1, 1. So if I go over here, that's just the vector 0, 1, 1, right? Plug in y and z there. 0, -1, 1. Same thing over here. We'll do a couple more so you can see what the vector field will be doing. Okay. So first we're going to plot these points, and then we'll go from there. Okay. So remember, these are the positives, positives, and positives going up. So we're going to go 0 on the x, 1 on the y. So let's just say this is 1 here. 1, 1, 2, 3, 5. Okay. All right, so 0 on the x's, 1, 1. So roughly here's that point. And we're going, there's nothing on the x, 1 on the y, and 1x. So roughly like that. Next point, now 0, negative. So this way on the y scale will be negative, and up 1. So roughly, let's say there. And this is going 0 on the x, negative, and then up. So like this. Okay. Now it's going to be x is 1, y is 0, and z is 1. So about there. And same thing, going positive, then up. And the last one, 0 on the x, and then both negative. So x is going down here to be negative. So it's about here, and it's going down this way. Okay. Now, if we keep going, so for example, if we put the point 3, 3, and 3, this is the vector 3, 3, and 3. So these are going drastically larger when it comes to these vectors. And they're all pointing away from the origin. And the farther away you go, the larger these vectors become. In magnitude, of course. Which is pretty cool. Now, the cool thing is we have computer generated that can generate vectors. So this is the vector xy, so ijk of y, z, x. So if I just completely flop these around, this nice little curvature of these vector fields come into it. So you could actually see the vector fields follow a nice little path, for instance, like that. Well, these go eventually go bigger outward, right? And these ones, for example, flow in this direction. So you can kind of think of this currents. And this one's a nice, interesting one because this actually has a hole in the middle where, like, you could think of it like a riptide. It just gets sucked in without it, and it doesn't actually close in on itself, which is pretty cool. And the biggest one, hence where all of this came from, Newton's law of gravitational is equal to this. If you're not sure, right, Newton invented calculus, so he invented it to describe what's going on here. And this is the vector field of gravitation, or gravity, which makes sense, right? Because if you jump up, you come back down. So the vector field of anything that's going anywhere goes back to the center itself, or in our case, the center of the Earth. So this was able to explain one of his famous laws of gravitation. So if you take physics, this is a big equation because this tells you how the force of what you would be doing on a force of gravitational on any type of planet or any type of, any planet. So if you see why the moon is like lighter than us, or the forces is actually less, you can jump higher, it's because once you graph its gravitational forces of vector fields, it does go to the center, but the force itself is not as strong. So this is really complicated stuff and really cool stuff once you get into higher mathematics and into physics itself.